All right, thanks for tuning in. My name is Brandon Clayton, the Algebra Guy. As you see on your screen, the discussion today is simplifying using commutative and associative properties. So you're probably pretty familiar with this actually, but maybe not the name. So let me show you what we'll be covering. So we're going to use the commutative and associative properties. Um, Evaluate expressions using the commutative and associative properties, and simplify expressions using these properties. So those are the three things we're going to focus on: using them, evaluating with them, and simplifying with them. So let's get to it. What is the commutative property of addition? The commutative property of addition simply says if you have a plus b, if they're real numbers, it's going to be the same thing as b plus a. Simple enough, right? That makes sense. 2 plus 1 is the same thing as 1 plus 2. $2 plus $1 or $1 plus $2. It's all going to come out to the same thing. I'll take them both. What about multiplication? Multiplication says the same thing. If you multiply a times b, it's the same as multiplying b times a. So think about commutative as commuting. That means to move as if you're commuting in traffic. What's the commute like? Well, that means what's the travel like? So it's like this A and B are moving positions. They're commuting. And it doesn't matter. With addition and multiplication, it doesn't matter. But with subtraction and division, it does. So that's why you don't see subtraction and division here. Because 5 minus 2 is a different answer than 2 minus 5. So keep that in mind, because one gives you 3, another gives you negative 3. All right, let's look at some examples. So multiplication of 10 times 5 equals what? Is that the same thing as 5 times 10? Would this be 5? Are these two equal? Well, you better believe it is. So that's one way you could look at, one example we could look at for the commutative property of multiplication. What about 10 plus 5? Is that equal to 5 plus 10? It sure is. And what about subtraction? 10 minus 5, is that equal to 5 minus 10? So 5 minus 10. Well, 10 minus 5 is 5. 5 minus 10 is negative 5. So nope, these are not equal. And same thing with division. 10 divided by 5 is 2. Well, what is 5 divided by 10? Well, $5 divided into 10 people is not going to give me $2 each. It's going to give me 50 cents each. So that's not equal. So as we illustrated, commutative property is useful or true with multiplication and addition, but not with subtraction and division. All right, so let's use the commutative properties to rewrite these expressions. So rewriting this will give us 3 minus 1. And this one will be 9 times 4. And we know that because we're adding and multiplying, it's going to equal the same thing. All right, what about the associative property? What is that? The property says, what if you associate two numbers here, but two different numbers on the other side? Will it still be equal? And for addition, like this is absolutely true. So if you're adding everything, you could couple two numbers and couple two other numbers, and they're both going to be true. Same thing for multiplying. So you can associate two numbers together and two different numbers on the other side of the equal sign, and they're still going to make the equation true. This is important when you're trying to solve problems because it makes your problem solving so much simpler. For instance, look at this. 7 plus 8 plus 2 is 15 plus 2 because we added 7 plus 8 first, because you do parentheses first in PEMDAS. Or we could have did 8 plus 2 first, which gives us 10 plus 7. But you can see that they both are going to give us 17. Same thing with multiplying. 5 times 1/3 is 5/3 times 3 is 5. Or you could have put your 1/3 and 3 together and just got 1. 5 times 1 is 5. Now, which way would have been easier? Well, you can see this way is much easier than getting a 5/3. You can just think, oh, that's going to be 1. 1 times 5 is pretty simple. So that's an example of how this could work in your favor. All right, let's use the associative property to rewrite these following. All we're going to do is regroup them, right? So instead of grouping those first two, we're going to group the second two as follows. Bam. And here the same thing. Instead of grouping these two, we're going to group the other two. -4. And we're going to put our 2/5 here times 15. There we go. So we're going to group these two. Now it's going to be the same answer, but I want you to get used to seeing what it looks like to use the associative property for addition and multiplication. Use the associative property of multiplication to simplify this. So how could I simplify this using that? Well, instead of writing 6 times 3x, I could actually do 6 times 3 and then times x. So I'll put the 6 and 3 together because those are numbers that can be multiplied together easily, giving us 18x. Now you could do the same thing and get an answer here, but you get the idea, and especially when you have a problem that's a little bit more complicated. So let's evaluate each expression using x equals 7/8. And I want to see if you can see something here. So 7/8 plus 0.37 plus a negative 7/8. So if I work this one, I would change this to a decimal. And let's go ahead and see what that decimal will look like. Now, hopefully you're already kind of seeing the answer without doing this because you use the associative rule, associative property. So if you see the answer already, it's because you use the associative property. But let's do 7 divided by 8 is 0.875. So 0.875 plus 0.37. So what is that going to be? Plus 0.37 is 1.25, and then minus 0.875 because this is the same thing. So minus 0.875. It gives us 0.37 again. Now, why? Look how similar these problems are. So let's rewrite this one, evaluating that 7/8. So this is going to be 7/8 plus a negative 7/8. 7/8 plus 0.37. And we use the associative property. Why? Because all we did was take the x that was over here and moved it closer here. So now you can easily see when you work this 7/8 plus a negative 7/8, well, that's just going to be gone to 0. There's nothing there anymore. So this is gone. And all I have left is this, which is my answer. So if you didn't see that before, you would have been left doing this problem, taking a little bit more time. So let's use that property when we see it. And I forgot that I worked it out already to save time. But you can see how it works out. Look at the work you have to do and the work you save here. All right, so in here, evaluate this expression when n is 17. We're going to put 17 here. If we put 17 here, and this is in parentheses, we need to multiply 3/4 times 17. 3/4 times 17 gives us 51/4. 51/4 times 4/3 is 17. Those 4s will cross it out. 51 divided by 3 is 17. What about this one? So this one's going to be, if I put the n on the outside and I move the numbers together, 4/3 times 3/4 just goes to 1. And now I have 17 left. So the whole point, as you're hopefully seeing, is it saves a lot of time if you can work, if you can use the associative property to connect like things that multiply out to 1 or add up to get 0 to make your problem solving that much easier. So same problem, we just moved that, we just commuted, right? This this is associative property. So we just associated this 3/4 and 4/3 together on this one, And we did that first, which made our problem solving a lot easier. All right, so let's do this one using simplified expression using commutative and associative properties. So what can we do to make this simpler? Well, I'm not going to write it all out, but you can see that this negative 84n and 84n, if I move those together, I would have just canceled them out to 0. So now what do I have left? Negative 73n. But if you didn't do that, you would have done negative 84n plus negative 73n, then added 4n, and it's going to give you the same answer. So use your associative property, use your commutative property, and move this one over, and put those together to get 0. All right, what about this one? On this one, I could use the commutative property and do 7/15 times 15 over 7. So I'm moving this one right over here, and then 8 and 23. And you really don't even have to move it if you don't want to, but it visually just makes it easy to see that this times this is going to give me 1. Because 7 over 7 is 1, 15 over 15 is 1. If you multiply straight across, 7 times 15, 15 times 7, it's going to give you the same answer, which is equal to 1. So 1 times this is just going to be that, 8 over 23. So at first it looks complicated until you realize, hold on, I have reciprocals here being multiplied. That equals 1. How can we make this one easier? So I would encourage you to solve this one. So since you know you're dealing with addition lets us, if all of it's addition, you can use commutative or associative to make this easier. And I see that when I'm adding fractions, I want a like denominator. And I notice that these have 4s, but these aren't in parentheses. So I'm going to put those in parentheses, 3/4 plus 1/4. I'm going to do those first, and then I'm going to do 5/13, because this is so much easier dealing with the like denominator. So 3 and 1 gives us 4. 4 over 4 is 1. So this is 1 plus 5 over 13. 1 is equal to the denominator of 13 over 13. So that's 13 over 13 plus 5 over 13, which is 18 over 13. So look how quickly we solved that. And this looks like a booger bear with all its fractions and stuff going on. But it was easy when you put your 3/4 and 1/4 together to get 1. And all you have left is this piece. So that's the power of using these properties, or knowing that you can do that. What about this one? So parentheses tells us to do that first, right? However, is there a faster way I can do this? Yeah, because I see that this 9.99 and this 0.01 is going to easily round up to the next number. So I'm going to actually do those first. 9.99 Q, looks like that's a Q. 1.01 Q. So I'm going to do those first and then do this last. Why? Because they're all adding, so I know I can move these around and still get the same number. So when I do that, 9 plus 1 is 10. 99 cents plus 1 cent is another 1. So that's going to be 11 plus 6.47. Well, that's easy math to do. 11 plus 6 is 17.47 Q. Should have put a Q there. So pretty simple. No calculator needed even if you use your properties. All right, what about this expression here? So we're thinking of doing 1.67 times 8 first and then doing 0.25. But I know this is going to be probably a funky looking decimal with this 0.67 times 8. However, if I put 8 times 0.25 together, that's pretty much asking me what is 8 quarters. So 8 a quarter 8 times is like $2. So this would be 2. I'm gonna double check that, or just show it to you that it's true. But I'm kind of like, hey, let me make sure that's true. 8 times 0.25, so yeah, it's $2. So see how quickly we already made our problem by putting the 8 and 0.25 together. These are all being multiplied. So I note the multiplication, we can use commutative or associative. What did I use this time? Well, I pretty much associated 8 and 0.25 together first, and then I'm going to do my 1.67. So what is that going to be? What is 1.67? I could just do it on my calculator, but I kind of want to do it, by hand just to show you. Let's see. 167. That's 1 2/3, which is the same thing as 5/3. So what's 2 times 5/3? Well, there's a 1 here. 2 times 5 is 10. That's 10/3. So as a decimal, we get 3.33, on and on. Let's double check it. We had 2 times 5/3. Oh, actually, that's tough to do in the calculator. At least this type anyway. So I'm going to do 5 divided by 3, which is my 5/3, times 2, and there it is, 3.3333. All right, and this one's simple. We're going to put our parentheses around 6 times 9, and then do x last instead. So that gives us 54x. How can we make this easier? Let's look for something that's going to make this. These are all, this is P, P, and the Q and the Q. How can we simplify this? Well, putting our Q's and P's together will be easier on our I. So if I put my 18P here, my minus 15P here, and then I did my 6Q, and my 5Q. So now I can just put these together pretty simply. And my Q's. That's supposed to be P, wasn't it? All right, so what property did we use to do that? Well, we just moved them around, so that was commutative property. Just to help with the logistics of solving that one, made it a lot easier. So we use the commutative and associative property. We evaluated using the expressions using them, and we simplified the expressions using those. So that sums up everything we were trying to cover, and we did it. Hey guys, thanks for tuning in again. My name is Brandon Clayton, the Algebra Guy, and I will see you next lesson.